Okay, test review 1 for your percent on Friday. Percent conversions on Friday. So this is your first one. So there'll probably be a couple more so that you can practice. All right. So the first question: Tina spent 40% of her allowance. If she gets $80 a week, how much did she spend? Okay. Well, let's get to this right away. So we're talking about percent. You can use a double number line, but just because we've done so many of these and we're working with equivalent ratios, let's just stick to this. 100 part total, this is percent. 40% goes over here. If she gets $80 a week, so that's the total amount she gets, so that obviously has to go here. Two ways of doing this: side-to-side relationship. If you're looking at how 100 becomes 80, then you're gonna have to simplify this. Actually, one way. Sorry. Let's divide this by, I don't know, let's divide this by 10. 40 divided by 10 is 4. 100 divided by 10 is just 10. I will no longer use this ratio, but use this simplified ratio, 4 over 10. How does a 10 become an 80? Easy enough, times 8. And on the top, it's going to be times 8. And 4 times 8 is 32. So 40% of our allowance equals to $32. It makes sense because 50% would be 40, so it's a little bit lower than 40. Okay. A subway rat measures 85 centimeters. A house rat, I don't know if there's such a thing as a house rat, but well, the ones that you find near the houses, measures 64 centimeter. How much bigger is a subway rat in meters? Okay, so I made these numbers up. No idea how much a subway rat, but they're big. 85 centimeters. So we want the answer in meters. Well, let's see what we have. The subway rat measures 85 centimeters. The house rat measures 64 centimeters. If you subtract, you get 21. So the subway rat is 21 centimeters bigger, but I don't want my answer in centimeters. I do want it in meters. So I'm going to have to change this centimeters into meters. If you look at your reference sheet, this is within the metric. You know that 1 centimeter is the same thing as, let me erase that. We're going to use that. We need to change centimeters. So 1 meter is how many centimeters? 100 centimeters, right? And on this side, I'm going to write meters on top, centimeters at the bottom, and 21 centimeters is what I want to change. So here we go. Side to side, not really, but up and down there is. How does 100 become a 1? Divide by 100. And how does 21 over here? It's going to be divided by 100. So if you take your calculator and you divide 21, not 100, 21 divided by 100 equals 0.21. Okay. All right. Or if you remember that trick, dividing by 100 means moving the decimal 2 spaces to the left. So the decimal was right here. So I'm going to do it at the bottom here. 21 centimeters. Decimal is here. If I divide by 100, I'm moving the decimal 2 spaces to the left. 0.21. Okay, so my answer is how much bigger? The subway rat is bigger by 0.21 meters, which is the same thing as 21 centimeters. 3. Linda read 60 pages of her book, which represents 20%. How many pages does the book have? All right, so 60 pages of a book, 100 goes here, so 20% will go here. And 60 pages is the part or the total? It's actually the part. So we want to find out how many pages this book has. So if she only read this much, 20%, which was 60 pages, what's the total number of pages in this book? Relationship? Ooh, easy. Times 3. Times 3 at the bottom, so we get 300. So the book has 300 pages, of which she read 60 pages, or 20%. Is of, next two questions. So percent goes here, 100%, 100% is of. It's just a different way of looking at the question. It helps you out. So 45% of what number is 18? 45% goes over here. Of what number? is our mystery, so the bottom here is going to be empty. And is 18 stands over here. So what's our total here? Okay, let's know 45 and 18, no relationship. Let's simplify. 45 divided by 5 is 9. 100 divided by 5 is 20. Now you can see that 9 times 2 is 18, so at the bottom, 20 times 2, and our answer is 40. Okay, so 45% of 40 is 18. Okay. 100 is of what percent? So obviously is our mystery. I'll leave it blank here. Of 120 is 80. 80 on top here. Any relationships here? Ugh, no. So let's simplify here. What can I simplify to so it does have a relationship with 100? Let's divide by 20. If I divide this 80 by 20, 80 divided by 20, it's going to give me 4. 120 divided by 20, it's going to give me 6. No, I don't want that. No, I actually don't want that. So let's divide 100 by 4. Not going to help me? No. Okay. All right. Divided by 8. Okay, so let's divide it by 10. If I divide it by 10, I get 8 out of 12. It's still no good. Let's see. Hang on a second. And if I simplify again, if I divide 8 by 4, no, 4 by 2. No, 8. Hang on a second. 4 divided by 4, 2 divided 4 divided by 2. 8 divided by 4 is what? 2. And 12 divided by 4 is 3. Is that going to help us? No, it's not going to help us. Okay, wait. Let me back up. Can I divide this by 80? Okay, divided by 10, that's 12. No, 12 and 100. Is there a relationship between? Okay, it's going to be a decimal one, but we can use it. So 100 divided by 12. No, there isn't. Divided by 260, that doesn't help me. Divided by, what am I missing here? Divided by 5. No, that still doesn't help me. All right, let's go up then. So let's multiply. Let's go higher. We're not going to simplify. We're going to make it higher. Okay. I'll multiply this by 10 and multiply the top by 10. So 80 times 10 is going to be 800. 120 times 10 is going to be 1,200. Now, is there a way of 1,200 becoming 100? Yes, I can divide that by 12. 1,200 divided by 10 equals 12. So divide by 12, and guess what? On top is going to be divided by 12. And 800 divided by 12, 800 divided by 12, it's going to be 66.6. I'm rounding to the nearest hundred. So if you use a calculator, you're going to see 66.6666 forever. Let's just round it to the nearest hundred, and you get 66.67. Okay. So this was an example of, in our case, of not scaling it, not simplifying it, but making our ratio bigger, and then finding a relationship. Okay. Ratio of lions to zebras is 3 to 7. What percent of the animals are lions? Okay. So again, percent. Part total. What percent are lions? So how many lions we have here? This is 3 to 7, so 3 of them are lions. And the total number of animals are 3 plus 7. Careful here. So 10. So out of the 10 animals in total, 3 of them are lions. What's the relationship? Times 10 times 10, and I get 30%. Okay. Am I still on the first page? Yikes. 7. Kim can type 40 words in 8 minutes. So let me write that down. 40 words in 8 minutes. All right. So I want to know how many words you can type in 20 minutes. Okay. So on the other side, I'm going to write words on top, minutes at the bottom. So here's my proportion. Is there a relationship between 8 and 20? Not really. Nothing times 8 gives you 20. But up and down there is. Please use advantage of that. How does the 8 come up 40? Times 5. So it's going to be here. Times 5. 20 times 5 is 100. You could have simplified 40 over 8 to 20 over 4, and then there would have been a side to side. So if you didn't want to do up and down, then you change 48 over 8. You could have had 20 over 4. And you would have had this on this side. Now there's a relationship between the bottom two numbers. Times 5, times 5. And notice you get the same exact answer. How many words can she type? 100 words. 20 minutes. A hallway measures 40 feet, 45 feet long. Okay, so 45 feet. Lynn says that the measurement in yards is 20 yards. Okay, is 20 yards. All right, so is 45 the same thing as 20 yards? I don't know. Is she correct? If not, by how many feet was she wrong? Oh, okay, so let's see what 20 yards equals to, right? Because if she's wrong, we want to know how much off she was in feet. So 45 feet stays 20 yards. If you look at your reference sheet, 1 yard is the same thing at 3 feet. All right, so let's change this. On this side, we have yards on top, feet at the bottom, and we want to change 20 yards. Times 20. Times 20. Which is 60. Sorry, 3 times 20. And so 20 yards in feet is 60 feet. Ooh, she definitely was not right. Was she over? Yeah, she was over by a lot. So 45 feet, how much was she over in feet? Well, she said it equals to 60 feet, but it's not. I'm sorry, 20 yards, which is the same thing as 60 feet. And the actual measurement was 45, so she was off by 15 feet. Okay, about 5 yards. Not about, exactly 5 yards. So she was way off. Takes Pam 20 minutes to run 4 miles. Ooh, fast runner. 20 minutes. And she runs 4 miles. And I'm going to write M-I-L, miles. How many routes can she run in 2.5 hours? Okay, so this is in minutes. That's miles. And on this side, if you write your proportion, it always should be minutes on top. And then write M-I-N, actually. And miles at the bottom. Notice that we have a problem here because this says 2.5 hours. 2.5 hours. We got to change that to minutes. Well, I know 1 hour is 60 minutes. Well, there's another hour here, which is 60 minutes. And then 0.5 means half. What's half of 1 hour? It's 30 minutes, or 0.5 of an hour. The same thing as 30 minutes. So I'm changing 2.5 hours to minutes. So 60 plus 60 plus 30 is 150. So 2.5 hours I changed to 150 minutes. Okay. And now I can find how many miles she can run. So 20 to 150. No, let me simplify. See if let me divide this by 2. So 20 divided by 2 is 10. 4 divided by 2 is just 2. So now I have 10 minutes. And in 2 miles, same thing. Now there is a relationship, nice and easy. 10 times 15 is 150. And 2 times 15, which is going to give us 30 miles. So in 2.5 hours, Pam here is going to run 30 miles. Okay. Good. Next one, percent, blah, 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 blah. Okay, so it's a percent question. Notice a lot of percent questions, right? Carol spends, so it's 100 here, 30% of the time in the weekend playing soccer. She spends 6 hours playing soccer, so how much free time does she have? So she has all this free time on the weekend, and 30% of that free time that she has, she spends it on playing soccer. So 30% is the same thing in hours as 6 hours. So how many total hours does she have? Because she's not playing soccer. All her free time on soccer is just 30% or a part of it. So we want to find out the total number of hours that she has free. I know that part of it, the 6 hours she plays soccer. So relationship, Yeah, there is. Divide by, how does 30 become a 6? Divide by 5. So 100 would also be divided by 5, and 100 divided by 5 is 20. So on the weekend, Carol has 20 free hours, of which 6 hours are spent playing soccer. Okay, not a bad way to spend the weekend. 11. In a class of 25 students, 30 are Brazilian, half are American. How many are not American nor Brazilian? So I want the number of people, the number of kids who are not American, not Brazilian. So let's set it up. 30%. Okay, so let me write things down here. 30% are Brazilian. Half are American. Half of the class American. So half, okay, is the same thing as saying what? 50%. 50% are American. Remember, percent's always out of 100, so which leaves us with what part that is not Brazilian, not American. So 30% Brazilian, 50 American. That leaves us with those 50 that added up to get 80, right? So if 80% of the class are Brazilian American, that leaves you 20% of here that are rest of the world. Rest of the world, okay? Wherever they come from. So that's the percent that I care about. Now, you could have done 80%, find how many are Brazilian American, and then subtract from 25. It's completely fine. Or you can do this. Okay, so I know that 80% of my class is American and Brazilian, which leaves 20% of the class that are not Brazilian American, and now put right here. That's the number of, that's the kids that I want to find out, the 20% that are not American and are not Brazilian. How many kids in this class? 25. That's the total. So is the relationship? Divide by 4. Divide by 4. 20 divided by 4 is 5. So there are 5 kids in this class that they're not American and not Brazilian, which means in this case 20. So 20 students are Brazilian American and 5 are not. Okay. Here's another not question. Survey of 300 students. 45% like vanilla, 25% like chocolate, 20 like mint, and 10 like strawberry. How many do not like mint? Okay. So, do not like mint means they like vanilla, they like strawberry, chocolate, but not mint. So I care about these people, and the strawberry people at the end. I don't care about the mint because that's not what I want. I want the people who don't like mint. And the people who don't like mint are the people who like strawberry, chocolate, and vanilla. So let me add them up. This is the vanilla people, 45%, 25% like chocolate, and 10% like strawberry. So the percent, by the way. If I add them up, 5 and 5 and 0 is 0, go 1, 4, 5, 6, 7, 8. So 80% of this particular group of students, they like strawberry, chocolate, vanilla, but these guys here don't like mint. So I'm going to put the number 80 on top. How many do not like mint? So it's 80% don't like mint. So how many students do we have here? Part total, there's a total of 300. Times 3. Times 3, and you get 24. So 240 kids like vanilla, chocolate, and strawberry, and they don't like the mint. Okay? Put the following order from least to greatest. Okay, so we have a problem here because they're in they're in meters, centimeters, and meters. So pick one. You either make everybody meters, or everybody centimeters. I'm just gonna pick meters. Okay, so I'm gonna leave this guy alone. Circle. I'm gonna leave this guy alone, and leave this guy alone. Why did I pick meters? Because 3 out of the 5 are meters, and I don't have to change too many. So I only have to change this guy and this guy. So if you go to your reference sheet, you know that 1 meter is the same thing as 100 centimeters. And here, over here is meters, centimeters, and I want to change the first one, 115. That's 115 in centimeters. Side to side, no, but up and down, yes. Divide by 100. Divide by 100. Divide by 100 means that I'm going to move the decimal from the end here, at the end to the right of 5, 2 spaces to the left. And this is going to become 1.15. So 115 centimeters is the same thing as 1.15 meters. Let's do one more. 1 meter is the same thing as 100 centimeters. And meters, centimeters, and what do I have here? I have 99 centimeters. How do I change that to meters? Again, same thing. Divide by 100. Divide by 100. Shortcut, move the decimal 2 spaces to the left. So the decimal is over here, so I'm going to move it 1, 2. It's going to come from the right side of the 9 to the left side of the 9, making it 0.99 or 0.99. Now the rest is easy. Everybody's in meters. Everybody in the same unit. I can put them in order. So let me write this right under instead of 0.99. So what's the order here? Well, the smallest number is 0.99. Then it would be 102. Think about it. 102. Then would be 115. 1.15. Then would be 1.5. Remember, 1.5 is 150, not 105. So 1.5 is the same thing as 150. Check. So they're gone already. And the last one is 1.24 meters. So in order, 0.99 meters, 1.02 meters, 1.15 meters, 1.5 meters, or 1.24 meters. Last one. What percent of the following letters in the word neurosurgeon are vowels? Round to the nearest hundreds if necessary. Okay. Hopefully you know what a vowel is. 100. That part total. Vowels are A, E, I, O, U. Okay. So in the word neurosurgeon, let's count how many there are first. How many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 letters. And how many of them are vowels? Well, you got the E, you got the U, you got the O, you got the U again, you got the E, and you got the O. 1, 2, 3, 4, 5, 6. So 6 of those letters are vowels. Wow, I made it easier. So 6 of the letters are vowels. What's the percent? Side to side, you're not going to see one, 12 to 100, but up and down, how does a 12 become a 6? Divide by 2. So here, I divide by 2. And 100 divided by 2 is 50. So 50% of the letters in the word neurosurgeon are vowels. Okay? And that's that. That's the first review.